Hello and welcome to the topic of cloud services or cloud computing. This is another new topic that has been added into CCNA Routing and Switching certification exam, and I'm glad that Cisco has added this one because really nowadays most of the enterprises are going for cloud services. Now before we dig deep into what is really a cloud service, let's just come to a point where we need to define certain definition. You see, cloud services is not a protocol and it's not one hardware or one software. In fact, it's a service. So in order for a service to be considered as a cloud service, of course in the domain of IT, it needs to fulfill certain criteria or certain conditions. First and foremost, it should be available on demand. So whenever I want a service, like I want an email service or maybe a software or any operating system, or I want to create a hardware, which we'll see in detail, that should be available on demand. So on demand availability should be there. Number two, it should be scalable, or as we call it, elasticity supportive. So scalability is this second criteria, and the third one is that it should use a resource of pools. So that would mean that if you have got maybe pooling certain items and taking out a specific one, so that is the same case over here as well. You pool the resources, hardware resources, and you assign those resources to the particular needs of your customer. So pool of resources, that is the third criteria for a services to be considered as cloud services. It should be accessible from different type of networks. So network accessibility, like you should be able to connect it through internet or maybe your private VPN or maybe your intranet or any other WAN point-to-point links. So network accessibility is another option. And also, of course, if you are using a cloud service, the cloud services provider, they should be able to bill their customers. So billing is the last option. It's not that the customer uses the service and the cloud service provider is not able to see or judge that what are the resources have been used or what kind of services have been used, and they are unable to bill it. No, there should be proper billing mechanism. The cloud services should be network accessibility from different types of networks. It should have a pool of resources. It should be highly scalable and serves on demand. So these are the basic 5 criteria for a service, IT service, to be considered as a cloud service. Do remember these one because I'm going to remove them. And when we'll go deep into the cloud, we'll see that these are the services that are available for the services to be considered as cloud. So I'm just going to remove this one. And before we go into the specifics of cloud, you see, cloud computing cannot really be understood if we have not got some basic understanding of virtualization, which is also a topic specifically mentioned in your certification guidelines, that virtual services and virtual network infrastructure should be understood. Of course, we'll not be doing any configuration. It does not have to do. Cisco just want you to have the understanding of these services. So starting off, let's say if you want to buy a new PC, what would you do? I'm not talking about server. Of course, we can relate to that one as well. But let's say you want to buy a home PC. What would you do? You would first pick the CPU, whichever CPU fits to your requirements. You will also consider RAM, then your hard disk or storage, and what else? Of course, besides keyboard and mouse and your monitor. But these are the 3 basic criteria that you would be interested in. How much CPU power you have got, how much RAM you have got, and what is the demand of your storage. These same three major items can also be mapped if you are buying a server that you would place in a data center, or maybe in your organizations or your enterprise or in your campus network that would provide services. That could be providing services of web, or maybe email, or maybe FTP server. Any service that you would require to have a server in your organization. Of course, that would be classified as a server because these are especially manufactured and made their motherboards and their power supplies. They are specially manufactured in a way so that they should be able to run 24/7. So earlier, and I would not say earlier, rather before the concept of virtualization, we used to have these servers residing in our server farms or maybe in our data centers in this fashion. And of course, they were like this much tall, maybe around 2 feet tall, and then they were having a depth of around 2 to 3 feet, and used to take up a lot of space. If you ask me, consider placing like hundreds of these servers in any room and then give them the power supply. And of course, since these are server class machines, they generate a lot of heat. So you need a proper cooling system over there as well, and then you need the Ethernet cabling with each of them. And if you are having multiple or redundant network interface card in each of them, then of course the number of cables would double. And you might also be having keyboard and mouse and monitor with each of them. Now these were the scenarios that we used to have before the concept of virtualization. But when virtualization came in, and even before the concept of virtualization, what we used to do is that we used to plug in, let me remove this figure, that we used to plug in servers into the racks. So the server hardware changed from kind of tower casing to blade architecture. And blade architecture really means that those servers were able to be installed in racks. So like this is the server, this is the front end, and these are the bolts, and this has been placed in the rack. Similarly, another server, just like the CISCO routers or switches that you can install or fix in racks, similarly those servers are able to be fixed in racks. And normally their height would also be 1 rack unit or 1.75 inches. So if you have got multiple servers connected in this fashion, you wouldn't have to attach keyboard and mouse and monitor with each one of them. Rather, what would you do is that there's a device which is known as KVM switch. So KVM switch, which stands for keyboard, mouse and video. That really means that monitor. And what we do is that we take let me change the color, take mouse cable, then keyboard cable and video cable, and plug it into this this box. Similarly, the 3 cables from this server as well, and 3 from this as well. And on the output of this, there would be provisioning for inserting 1 keyboard, 1 mouse and 1 video. And there will be a switch over here. So what really helps this one out is that you can, based on the switch flipping over here, you can select that what particular server or machine would you be accessing using this KVM. So once you flip this switch, you can connect to this one. You switch it again, you can connect to this one. So really you do not need to have multiple keyboard, mouse and monitors for each one of them. So that is the first, I would say, stepping stone where you kind of removed the accessories that are used to manage the servers. Now this scenario was all good and it used to serve us well. But look at this one. All these servers, they used to have one operating system. And you would be running different services on each of these servers. Now it is quite possible that at certain times you would not require this server for that particular service or for that particular platform. then what would you do? You kind of completely erase that operating system and install a new one. And it is also possible that at times your server, the hardware, the CPU, the RAM or the hard disk that you have allocated to each and every operating system, they may not be optimally utilized. They may be underutilized because that is not the requirement of that particular OS and the application running on the server at that particular moment. So kind of wastage of resources. Although before the advent of virtualization that was not realized, but the technology as it advanced, people did realize this thing, that we kind of waste our resources, the computing cycles on the hardware, and it is not optimally utilized. So when technology evolved and people kind of and not only technology, rather demand also grew, it was not possible to manage all these servers in this fashion in the data centers. So then came the concept of virtualization. And let me remove this figure and draw a new one for you. Now from a physical server or host machine, as we call it, from the physical machine perspective, what it really has, it has got CPU. It has also got RAM. I'm just going to draw the main components and the storage, right? And on top of that, you would install the operating system. And on top of operating system, we would be installing different applications. So that is the scenario without virtualization. What virtualization does is that let's say if we have got CPU and RAM and storage, then instead of installing operating system on top of this hardware, a virtualization layer which is known as hypervisor, that is placed. That is a software which is placed on we can place it on OS as well, but if you want to, or as for production network, it is recommended and best practice is that it is installed on bare metal. That because if you are installing a hypervisor which provides this layer, abstraction layer, that we can use to install different operating systems, if it is itself residing on an operating system, then inherently those weaknesses that are embedded in the OS, they will be transferred to your virtual machines as well. So we put in hypervisor like in this fashion, a layer of hypervisor which manages the CPU, RAM and storage, and on top of hypervisor, let me see which color, on top of hypervisor will be different machines. So these are the virtual machines. Now let me say like 3 virtual machines. So each VM maybe 1, VM2 and VM3, and on these 3 VMs you could be running OS 1, a different OS could be over here, OS 2 and OS 3, and they will consider, because of this particular abstraction layer, these 3 operating systems and these 3 separate virtual machines which will have their own CPU, RAM and storage. They will consider as if they are using that in total isolation. They will not be considering that I'm using a shared resource. No, that is the responsibility of hypervisor to make it look like this hardware, this pooling of hardware and allocating certain CPU. Let's say this CPU is of 8 gigahertz and we have allocated out of this 8 gigahertz 2 gigahertz to this particular machine, then this would consider this as solely and wholly 2 gigahertz at its disposal. Likewise is the case for RAM and storage, and similarly these 2 other machines will consider as if they have been allocated physical hardware at their disposal on which you have installed the particular software or operating system, and on top of that you have installed particular applications. So the key point here to remember is that an abstraction layer, which is known as hypervisor, which provides the services of these virtualizations to make virtual machines. They are virtual in nature because they are not in fact hardwares, but hypervisor make these machines look like they are multiple hardwares, having virtual CPUs, virtual RAM, and virtual storage. Now the benefit is that since these are all softwares, these virtual machines are softwares, I can simply remove this one and create another one. Likewise, I can remove this one and create another one, or I can remove all these three. I do not need to change my hardware. I can remove all these three and make one virtual machine, or maybe make 5 out of them by just assigning different CPU power, RAM, and storage. Now in this figure I have used one CPU, RAM, and storage, but the idea really is of virtualization is that you could have multiple CPUs, multiple number of RAM, or a huge chunk of RAM, and a huge storage that you can pool together, and out of that you can allocate different CPUs, RAM, and storage resources to different multiple virtual machines, of course through the abstraction of hypervisor. Now in production network there are some industry, I would say virtualization abstraction layers are available, or hypervisors are available, that I should mention over here. One is Citrix. I have used this one personally. It's a very good product, and their product name is Zen Server. Citrix is the company and their product name is Zen Server. We also have very common, if you have heard about it, VMware. Their product is vCenter. Microsoft is also providing one, which is known as Hyper-V. It's Roman V. And Red Hat has also got one, which is KVM. This is not I would say keyboard, mouse, and video, but rather this is kernel based virtual machine. Now I talked about installing hypervisor directly on the hardware, but of course you can put it on software as well, and the services that you can use is there is a product from Oracle, which is VirtualBox. You can install it on Windows or maybe on your Linux operating system as well. And also VMware also provide a free hypervisor service for your desktop environment, which is VMware Workstation Player. So VMware Workstation Player. Now let me quickly show you how an interface of VirtualBox, which is a product of Oracle, looks like. Now this is the interface of VirtualBox. I have created 4 machines, WinXP. This is Juniper based machine, and this is CentOS, which is a variant of Linux, and this is Ubuntu operating system. And you can also see over here in the details that I have allocated 1 GB RAM to Ubuntu. Over here I have allocated 2 GB RAM, and for let's say Windows XP I have also allocated 1 GB RAM. Now it is pretty easy to install and configure machines in these freely available platforms, but if you are not very sure, you can check my course, which is Learning Linux through Ubuntu and CentOS, and in those very lectures, at the start of those lectures, I have mentioned and shown how you can install these softwares. First download these software and install these operating system onto them. So do check out if you are unable to do it by yourself. So let's say if I am here at Windows XP and I want to, let's say, run this operating system, I can simply click on Start, and this Windows XP operating system gets to boot up.